Hey, thanks for watching this. This series of 2 videos are classes that Bert gave at the new apprenticeship program that we started along with Lake Technical College in Eustis, Florida, and with the state of Florida. So it is a registered apprenticeship program. Some of the people in the class are KLOS employees, some are employees of other local contractors, but they are all working in the field. So the bulk of their education is occurring in the field, and then 6 hours per week, 3 hours per night, 2 nights a week, we're giving these classes. And you're gonna notice that we really try to focus on things that can be applied pretty quickly. We are using the refrigeration and air conditioning technology manual by Cengage. If you are in need of a really good guide to learn more about the trade, I would strongly suggest all technicians have a copy of the racked manual on their truck. It is a indispensable resource for our industry, and that's what we refer to. From time to time, I may reference the section of the book that we are in. We're not going to read directly from it or anything like that, but if you want to follow along as we go through the apprenticeship program, whether it's Bert or I doing the classes, we're going to refer to it. Now, of course, it's Bert. This is his first time ever teaching in any sort of a structured environment, so it gets a little interesting. You may notice some verbal typos here and there, but it's real life. So hopefully you enjoy. Here we go, Bert Life, starting with day 1 of the apprenticeship program, talking about some basics, including things like tank fill and some safety basics when handling pressurized cylinders. Enjoy.
Woo! Wow, I did it. Never done that before. Okay, so if you have a break on one of your legs, okay? And then you take your meter and you check from here to ground. You know you're going to have 120, right? We got no break. The break happens inside this breaker. We got a failure here, okay? So this is our problem. Failure on this breaker right here. It's open. Stupid breaker. And so we know we're going to have 120 on one side, right? But in real experience, what you have is you test from here to ground to see if you got your proper voltage coming in. You got 120. You go to the other side, you test the ground, you also have 120. But when you check between the 2 points, what's my incoming voltage? It shows you 0 voltage. So when you're using a meter, the meter 2 leads will show you potential difference between the 2 points that the meter touches, right? So it doesn't know how much voltage, it doesn't necessarily show you how much voltage is at the point you're touching, but it tells you how much voltage is there a difference between what you're touching with this side and this side. So let's say that your unit was grounded. Let's say you had some voltage bleed over into your unit and it wasn't grounded well, so it wasn't tripping the breaker, and you had, like, I don't know, 20 volts on your unit. So if you touched it, you could get shocked. Well, if you use that ground, the 1 lead of your meter, and you touch the other side to your high voltage 120, it's only going to show you 100 volts of difference, because one of your points already has 20 volts, and then you're touching 120, and you have 100 volts of difference between the 2 points on your meter. So this is what's happening in this situation. This one that actually still has voltage, it's unbroken, is going down through the windings of your motor and coming back onto this leg through the winding of your motor and down to the bottom of the contactor. So you have this 120 all the way around on this side. So when you put your meter between these 2 points, it shows you have 0 difference of electrical charge between those 2 points, because it's the exact same leg coming through here. Your meter will show you 0 volts, but you go to touch it, you'll learn really quick it's not actually 0 volts. That's why a safety check is always a safety check, one side to ground, one side to what you're going to touch. That's a safety check. You go to ground, you got 120 and 120, but they're the same leg of 120, and it's backfeeding through the motor that's not operating and back to the other leg. So that's why you come up, you get 120 on one side, 0 volts between the two. You know, somewhere back here, my line is broken on one side. So is that pretty easy to follow? Cool, cool. Pressurized cylinders should be chained to and moved safely on an approved cart. And you actually have the picture, and here we have it in real life, moving a nitrogen tank of that size. Anybody know why that's important? Yep, if the cylinder accidentally falls, the protective cap can, well, actually we haven't talked about the protective cap yet. We'll go to read that. But if it falls, so you're just walking with that, and you hit a little stone on the concrete, and it falls, and you crack off the head, like which could pretty easily happen. The head could hit a curb, so it's the first thing that actually hits when it falls. Then you have a missile, like straight up missile. There's thousands of pounds, like over 2,000 pounds, usually inside these tanks. And you crack off a head without any regulator there, and that thing will actually, I've heard stories of them falling out of the back of people's vehicle. Like, you know, you see the trucks come in with giant tanks and there's like reloading at the shop or something. Someone not strapping it and falling off and just flying in different directions through traffic. Because, yeah, it'll actually make a bomb. There's actually a really great illustration of that on the next page. If that happens, make sure you lay in this exact position that the guy in the green shirt is laying, and the nitrogen tank will pass through your leg and over your head without making any contact to the body.
Can we get
A demonstration? Okay, hey, so, all right, you are gonna get a demonstration. So this leg, you can't really tell from the picture, is up like this, and your head's like that, so the nitrogen tank will go, and then, and you'll be fine. Guaranteed. That's already open, that's good. And this one is too. Okay, so if we open our tank, let's see how much pressure we have. So the first valve actually shows us our pressure coming out of the tank. So currently our tank is at 100. No, wow, our tank is at 1,500 PSI on our oxygen side. And then as we close down the regulator on this side, we're actually adjusting the pressure that it feeds out into the tube. So you can see that happening right there. So now the pressure's coming up on our oxygen going down into our actual torch. So that's a regulator in action. And you can see that's a really high pressure sitting right here. And actually your oxygen tank is probably the most dangerous thing on your entire van. Even though the gas is flammable, oxygen is what will allow a massive explosion. It's the kind of thing that can take out like a whole warehouse building. You have oxygen is needed for a fire. So the larger the fire or the larger the explosion, the more oxygen is actually needed. So if you have a gas tank explode, it's going to be a decently limited fire. You combine it with oxygen, it's a bomb. So that's the difference between, so oxygen is actually probably the most dangerous thing that we are transporting or have in our warehouses or carry around. So just because it's not gas in there, still got to respect it. And it's at high pressure. So if we open our gas side, our acetylene now, and this tank is empty. So you know what? Enough of that. That is an awful demonstration. Thanks a lot, my assistant. Thank you.
Only one course set out there.
Yeah, well, so this is now a safe acetylene tank. Always stock them on your van empty so that they're safe. Yeah? Yeah? Okay. So if you come over here and look at the tank, it's going to have a number listed on here as the tier weight. So find that on the tank. Tier weight is abbreviated by TW. And then it'll show you the pounds. All right, this guy knows. David's right. So the tank, without any refrigerant in it, without anything in it, this one weighs 28.4 pounds. So completely empty, that's your baseline. So if you're adding refrigerant, you're gonna weigh it, and you're gonna, okay, how many pounds is actually in here? You weigh the total, take out the tier weight, whatever you have left, it's gonna be how much refrigerant is in the tank. So I'm gonna take this off, and then who wants to do that? Good. All right, somebody, go ahead and just wear your safety goggles since we're working with tanks under pressure. So it should be 16 pounds of refrigerant in that tank.
16 and 3/4.
That's what we're left with. All right, so what was the tier weight again?
28.4.
And what's the total weight?
45
45 total. Okay. All right, the tag said 45 pounds. I thought it meant it had that much refrigerant in there. I was freaking out a little bit. So how much did they add?
16.
16.
16 and 3/4.
Okay. So actually for a tank this size, we're almost at full capacity, but we're not quite there. You could put another pound, almost 2 pounds in. Okay, so the other number on here is the volume, which is in water column. Where's that at?
Here,
And how much is that?
47.6.
Okay. So 47.6 is the water column. If you fill this tank with water, how much volume can it actually hold? You don't want to ever, if you were adding water to it, you would, you figure out what 80% of that would be. But refrigerant is actually, it's a different pressure, a different density than water, right? This is listed for water column as like a base number, but you have to know exactly what refrigerant's going into, and then a way to figure out, you got to change this water column density and match the refrigerant that we're actually working with. So the reference guide that I go off of is Brian's article that he wrote and he put online, or he figured out a lot of the math because it can be kind of tricky. Figure that out on your own. And then, and so when I'm trying to figure out exactly how much, I got a new tank, how much can I actually fill out, I'll usually pull up something like that article or a calculator online to figure out this refrigerant, this tank, how much can I actually fill it to get to 80% capacity and make sure I'm not going over. So what happens if you do go over 80% capacity? And if you come up and you touch this tank, you can feel the temperature. It's probably, I don't know, that feels like 74, 75. What would be, anybody want to pull up a PT chart, or we can look at this. If we have a saturation, so first of all, I guess I should go over that. Your tank has a mixture of liquid in the bottom, right? And then it's, at some point, there's vapor in the rest of it. So inside this system, you have a mixture of both liquid and vapor. It's permanently at a saturated state at all times inside this tank. As long as there's liquid in there, you're going to stay in a saturated state. So if you add heat, you'll burn off a little bit more refrigerant. There'll be a higher PSI, and once it reaches that PSI where the amount of heat you have matches the saturation, it'll stop boiling and it'll just sit there. So all of your tanks are going to be at saturation for whatever pressure they are. So we don't have any idea exactly what refrigerant we have in here, but we can, if we know the temperature of the tank and we look at the PSI of the tank, then we can actually figure out what type of refrigerant do we have in there. Okay, so let's do that. I'm guessing we don't have water in there. So usually, most of the work I do is going to be either R22 or 410A. And so it's a pretty big difference in pressure between those two. And hopefully somebody hasn't mixed refrigerant in there, or else you're lost. You have zero chance of actually knowing what you got in there. Anybody else want to hook up? You got gloves, so you're going to hook up. So go ahead, since we don't have...
Take it off the scale?
Yeah. Since we don't actually have a low loss on this, just hook up to the vapor side. Wait, do you know which one's the vapor side? Don't get thrown off by the blue and the red. Your vapor is actually the blue side, and they keep it blue because on an air conditioning system, your low pressure is vapor side, right? And your high pressure is your liquid side. So they go, blue is for low pressure, and red is for high pressure. That doesn't tell you if it's vapor or not, but they actually list on here liquid and vapor on the tank. So if our tank is liquid in the bottom and we have gas up top, but both of our valves are up here, why would they not both just be vapor? So it's the same tank, but coming off the bottom of red, this tube goes down and draws from the very bottom. So if there's liquid in there and you open red, it'll spray out liquid right here. You open your blue, which is your vapor, and it's just barely sticking into the top of this tank. There's no tube. So if you took the tank and you flipped it upside down, so, yep, and then you opened it up, now your red is going to be drawing from the top where there's vapor. The liquid sink down to the bottom, and blue would spray out. And they actually say that it's a little faster to recover that way. If you recover upside down, then you don't have the extra resistance that that tube places on it. It's a really small tube into the tank, so you can flip it upside down. You need to recover in liquid for fastest recovery. But if you flip it upside down, now your other side's liquid. You can recover into that, and you don't have a long tube. But honestly, it's such a small difference that I'm not sure if it's always worth it. Just depends on the size of your equipment. A lot of the stuff I'm doing residential, it's not going to make a difference for me. But if you're pulling out suddenly 20 pounds, more than that, a couple 100 pounds, you know, it's suddenly going to start making a difference that you do every little trick you can to save yourself on speed. But that's not a safety thing. That's just a trick for using that. So go ahead and hook up to the vapor side. So this is an analog gauge, and it has a handy dandy built-in PT chart on the gauge. So that's nice. Otherwise, we could look this up ourselves and find out. Okay, go ahead. Open it up. All right, and where are we at? Yeah, so you find what closest matches the temperature of the tank. So the tank's probably not actually as cold as I thought. I never actually took the measurements, probably in the 80s. And so if you come look at it, your scale's showing you the different PT charts at this pressure. So at this PSI, what's our saturation for 410A, which is the pink? The temperature of this tank matches closest to the 410A refrigerant, so we can assume we have 410A refrigerant in the tank. Now, if our tank was sitting outside and it was actually 120 degrees, we would have the same pressure, but we very likely have R22 in there. So if we have 120 degrees on this tank, we would expect R22 refrigerant to push us all the way up to above 250 psi. So that's a way that you can tell. And I don't know what's in this tank either, so we're going to go ahead and look at that. Close the valve. Let somebody else take a look at that. Almost nothing, huh?
Almost nothing.
Empty tank?
Pretty empty. Yeah.
Oh,
Yeah.
very unhelpful.
Yeah, it
What
will
do we
be
got?
10 PSI.
10 psi, so that you have no idea what is in that tank. Almost completely empty, so that was unhelpful. Well, we can use that at least to this tank for weighing. So let's do that. Let's weigh this tank and see how close we are to the tier weight. I'm guessing at 10 psi. How much weight do you think we have with 10 psi?
Probably nothing.
Probably nothing. You're exactly right.
Less than a pound.
You're probably going to be, you don't even have enough for any liquid in there. You're just probably going to be exactly tier weight. 28 point what?
28.8.
Okay, and what's it say the tier rating should be?
28.4.
28.4?
Yeah,
All right, so we're empty.
28.4.
Yeah, we can't trust our scale to actually give us that accurate of a on the dot. But yep, we're definitely empty. So we got an empty tank. It's ready for 80% capacity of refrigerant, and another tank that already has how many pounds? 16. Let me look at a quick reference that I pulled up from Brian's article. If you can look up a calculator for recovery tanks so that you can convert your water column into whatever type of refrigerant you're using, and then you'll be able to know what your full capacity is. Or I'm going off of the article on hvacschool.com that Brian wrote on it, and he wrote down the numbers here too to make it easy. So if it's 410A, you would multiply the water column by 0.56 to find a safe fill weight. Water has a liquid density of 62.42 pounds per cubic foot. R22 has 66.71. 410A has 54.70. So that's why you got different actual density. That's why you actually have to look it up. So instead of doing the whole equation, you could know if you're working with 410A, 0.65, multiply the water column by 0.65. Use your water column of your tank, 47.6, so that's your first number on your calculator, and then times 0.65. And the way I found this was I just Googled HVAC school refrigerant recovery tank, and yep, that's the one. And you just pulled it up, and then you can go down there, find a place where he's done the math for you with different refrigerants, kind of handy. 21 would be 80% capacity for a tank this size, 21 pounds. And so let's talk about, these things are listed as water column, but there's a pretty huge difference between when you start adding heat to refrigerant, how fast it responds in pressure to heat, than if you had, water sitting in this tank and it got a little bit warmer in your van. So if you have 410A refrigerant and you're sitting in the van, and let's say it gets up at 120 degrees, let's find, somebody do that. Find 120 degrees, probably going to see it on here, on the 410A scale. Tell me how much PSI that would be. 440 PSI. So if your tank gets that hot, that's how much PSI. Now here's the problem. If you filled it all the way up with liquid, and then it gets that hot, and you have that much pressure in there, that's when hopefully your valve's working really good, because you're going to blow out. Otherwise, you'll explode your entire tank when that starts getting that hot. So that's why you leave that room for it to expand inside that tank and fill the rest of the pressure. And then according to the rack book, we just said a lot of these are set over 400 PSI, and it can start coming out of there. Like I said, I've seen it get 450, somewhere in that range in recovery sometimes, and I haven't had it blow out. So that could have just been tank, that situation, or there could be a little bit of give in that. But if you're driving your van, things are getting hot back there, you overfill this tank, very likely you're going to start hearing a massive hiss if it's doing its job right here, and if it's not, then that tank will explode. So let's not ever overfill our tanks. Remember, your tanks, if they have refrigerant in them, there's enough that there's actually liquid in there. It's always at saturation because you have part liquid and part there. So that's where that temperature on the scale, the temperature is a saturation number. So this tank was at 80 something saturation. And so because we know the PSI, we got the exact saturation number for 410A or any other refrigerant at that PSI. So measure how warm your tank is, hook up your gauge. Like I remember times in the winter that I was taking out my R22 tank out of the van and it was really cold. And I hook up my gauge. Instead of normally seeing like I would, like 150 PSI would be pretty normal for an average day. It was down in like the 80s. It was like really low, and I'm like, oh man, my tank's empty. But it wasn't actually my tank was empty, it's just the tank was so cold that the pressure actually came down. So this is especially handy when you have a system that you don't know what type of refrigerant is in it. As long as it's been sitting and part of the system, it's stabilized long enough that it's stabilized, part of the system has liquid in it, so there's enough refrigerant for that. Part of the system will have vapor. You hook up your gauges, and you usually, it's about outdoor temperature. You look at your coils, it's outdoor temperature. Try to match somewhere around outdoor temperature. Which one of my refrigerant saturation lines up with this outdoor temperature? And that is the type of refrigerant you have in there.